Hi, Christopher Brown here, back with another video for Easy Breezy Math. In this video, what I want to talk about is graphing linear equations and how they should be presented, introduced, and taught into the classroom. So there's a lot of different ways to do graphs for equations, all right? One of the things that students need to know is that there are three ways to represent a mathematical situation, right? There is the equation, which the mathematical equation with just numbers and an equal sign. There are words. You could write out the actual situation that the equation is coming from. And there is a graph, which we call a visual representation of the math itself. Okay. So in this video, we're going to talk about getting that visual representation just for linear equations. I think I'm going to do a lot of videos on graphing. I mean, it might need to make a playlist with a section just on graphing, but this is one of the ways we want to start off with linear equations. Now, traditionally, I know that we start off with doing a lot of things with the T-chart, and we do our T-chart and we have our X on one side and our Y's on the other side, and we go through and find the values. That will probably be a different video, but for this video right here, let's just take a look at our simple equation with our Y equals X, okay? So as you see, I have a lot going on my whiteboard today. We're going to start right here up in the left-hand corner, and we're going to talk about the simple parent graph of a linear equation, which is y equals x. And there I have y equals x. If that were on a T-chart, you would have your list of x's and your list of y's, and they would all be equal to each other. So that gives me a series of points, right? 0, 0, 1, 1, 2, 2, 3, 3. And what it ends up doing, it ends up forming this line. I can also get negative numbers. X is -1, y is -1. X is -2, y is -2. And here, to keep going, if x was 4, y is 4. So they're equal, and I end up getting a line directly through the middle of my graph, and that's that blue line represented right there. And that's the parent graph. It's just your standard parent graph for y equaling x, okay? So we have that right there, our parent graph. Didn't mean to cross it out, but I think you know what I mean for the parent graph, all right? So what I like to do from here is start off with this parent graph, and I use Desmos a lot to do these. Desmos is great. It's a great program to use to show graphing. And what I'll ask the question next is what happens to this line if I add in a +2 at the very end of it? And I want students to guess. I want some conjecture here. I want them to think. I'll present it as a question. So this question comes up, what happens to the graph if I just put a +2 at the end? And some students will know. And what we'll end up actually doing is putting it into the program Desmos, or I could show it here. And right here, you'll see this blue line with the +2. What happened to the graph? So then I'll actually graph it and say, well, what did happen when I put the +2 in? And they'll see that, oh, it moved up 2 spaces. This is the 2 where it crosses the y-axis now. If I numbered these, it'd be 1, 2. I did not number the graph. That was a lot of little, it would look even more convoluted. It would be too crowded with the numbers in there as well. So I have a 1, 2. This is also like a 1, 2. But right there at the y equals 2 is where it crosses. And yes, that is called the y-intercept. So my y-intercept is where it crosses the y-axis. And I've shown that there. I've taken from the parent graph, and all I did was a +2. And so we're still talking about it. We're still getting different ideas here. The next question is, okay, that's +2. What happens if I put in a -3? What would I get if I had y equals x minus 3? And there'll be some thought about it, and I probably will get an answer. If you think about it, what would happen? I'm asking you now, what would happen if I put in a -3? And if you say, well, it's just going to go down 3, you would be absolutely correct. It would go down to the 3 right there. And since this is a 1 in front, I would go up 1 over 1, up 1 over 1. It would cross again at the 3 there. And I end up getting the same type of line with the same type of rate going directly across, see if I can draw that straight, through there, through the 3. And just about right, a little off there on my docs, but that's not a big deal. We want to get the idea that this same line that started off here from my parent graph, y equals x, was just moved down 3 spaces. So now they're starting to see what this number does on the outside. It moves the line up or down. Just like the y-axis goes up and down, it is called the y-intercept, okay? And I'll just go ahead and write it one time here. Y-intercept equals 3. Okay, we'll just write that in there just one time, just because that is what it is, and there's no problem calling it exactly what it is. It's a y-intercept, okay? So now that's the first movement that we have. Now I take a look at this next one over here, and I say, okay, so what's going on in this equation right here? I have two different numbers, right? Now I have my plus one, so I know what that did. That moved it up. But then the question is, what did this number do? What is this number right here? And I know what you want to say. You want to say that word, but I'm not going to say that word yet. We're going to call this the rate of change. That is my rate of change. That tells me how high I'm going to go up and over. It's a rate. It's a rate. Well, what do you mean by a rate? A rate could be miles per hour, right? A rate could be dollars per hour. You get a new job. For every hour you work, you make $10, right? So if you work 2 hours, you get $20. If you work 4 hours, you get $40. One number is dependent on the other. And so it's a rate. It's a rate of change. That rate is always in two numbers. I love to call it the rate of change because as soon as we get to talk about it as being a rate of change, we have to remember that, okay, that's usually two numbers, right? It could be, I have a leaky faucet and it's leaking a certain number of gallons per hour. Okay, two numbers always in the rate. Okay, so that's my rate right there, 1/2. The first number is, as you guys know, and we all teach, is how far we rise. The second number is how far we run. And that's fine to put that in, rise over run. Again, that's my rate, and I want to understand it that way, okay? So a great place to start when we're graphing off, when we're starting graphing, we start seeing graphing, is to say, well, we're going to start with your y-intercept. Why? Because it's just an easy place to start. So I start there, I put a point there on my y-intercept of 1. I put my point there, then I would follow this rate, and I'd go up 1/1, 2. And I'd show it just like that. And I can do that again, up 1/1, 2 spaces, just like that. And I put another point and I put another point. I can go down 1 and back 2 as long as it lines up. And I would say it just like that. But I would go ahead and draw that line. I like to ask questions like, hey, what do those arrows mean on the line? Well, the arrows mean it goes on for infinity. All right. So it's more of a direction. It's not something we see in real life. It is in a way, but it also isn't in a way, okay? Don't worry too much about that. We can kind of get the concept of infinity going on forever, and that's what those arrows mean. All right, so now let's take a look at this one. What would this one mean? Well, I've got the same two numbers here. I've got a number here and a number here. This one is my -2, just like this one went down 3. This one will go down 2, and I'll put a point there right on that y-axis. Mine's blurry. It's getting black and red. Right there on that y-axis, and then I would follow my rate. My rate is real simple. I do my rise over run. Again, I don't want to complicate things. I don't have to necessarily rewrite it. I'll just write rise and run in there. Real simple. Go up 1/1, 2, 3 spaces, put a point. Up 1/1, 2, 3 spaces, put a point. There's my rise over run. There's my rate. I connect the dots, and I have my line. Okay, so if we do this correctly, we'll have a nice line going straight to there, but I have graphed it and I've used my y-intercept and my rate of change. All right, let's take a look at the next one. Now we're just looking at some more examples. Here you may see this rate as one number. So this is where we ask the question, how can I change this number into two numbers? How can I make it into a fraction? Well, any number is a fraction if we just divide it by 1. So any number is the same if we divide it by 1. So the same value then would be the 3/1. That would give me my rise, and that would give me my run. So from this one, I would start off at my 2, and then I would rise 3, up, 1, 2, 3, and then go over 1. Put a point. Connect those dots. How many dots do I actually need for a line? Really, technically, I only need 2. I'll also go down 3, 1, 2, 3, and then go back 1. And I'll just do that for now. I'll explain how that works a little bit later with my students usually, but this is a great way to introduce the graphs, to get them to understand them. And let's continue on here. This one, I'd start off at the -3, and then this is a whole number, so I make it a 2/1, That is my rise over run. I'd go up 2 over 1, up 2, 1, 2 over 1, up 2 over 1, and I end up with my line going just like this through the graph, okay? So I've graphed this line using um, this linear equation using my y-intercept and my rate right there. Let's look at one more example down here. This one I wanted to include because this one has a negative rate now. So we'll notice that my rate of change is negative and it's going down from left to right. All the other ones were positive. They were going up from left to right, like we're reading from left to right. But this one is actually going down from left to right. So here I start off at the 2. And now for my rise, since it's negative, most students get this right away. Since it's negative, I'm not going to rise up 1. I'm going to go down 1 over 3, down 1 over 3. And we always go over to the right, down 1 over 3, down 1 over 3, and there I have my point. I have my line. I have my points, and then I connect the points, and I'll have my line. Let's graph this one starting off at the negative 1. This one says down 2 over 3. Down 2 over 3. So I'll go down 2 spaces, 1, 2, then over 1, 2, 3. Down 2 spaces, then over 1, 2, 3. Right about there. And I'll have my line going through just like this. These lines go and continue on forever. And there's my line. I have graphed that equation using my y-intercept and my rise or run. Again, there are many different ways to graph. What you want to do, first of all, is have them see this parent graph and memorize the fact that when I see this y equals x playing just like that, I know that that forms a line. All the numbers do is move that line around. And once they get that concept, that's going to be a great concept for them to take that and apply it to other different information and other different things. Of course, this is in one form. It's not standard form. It's called y-intercept form, really obviously slope-intercept form, because it has what we call, I'll say it now, I'll say that word, the slope and the y-intercept. And at the very end, after we've introduced it, you could say, oh, by the way, they'll call that rate of change, that rate, they'll call that a slope. But again, don't start with the vocabulary. Go ahead and say the definition of the word. Talk about what the words mean. This breaks down that barrier and we can go directly into the concept. And that's what we want to do. My last example here is of a water leak. And we want to talk about why are we doing this? Why are we having this visual representation? Well, because I can compare all these lines together, right? If I have a water leak and I want a visual representation, let's take this one water leak here. The one in red has a rate of 2 over 1. So that starts off at 0, 0, and I have my hours down here and my gallons up here. So what this is saying that every 1 hour, it's actually leaking 2 gallons of water. 2 hours, that's 4 gallons of water leak. 3 hours, that's 6 gallons. 4 hours, that's 8 gallons of water that is leaking. I want to fix that leak. I want to get to that leak really quickly. It's going up real fast. And I can compare that rate to where this one, every 3 hours, it gets 1 gallon of water leaking from that pipe or from that faucet or whatever I have that's leaking. So here I'll go, 3 hours goes up 1 gallon, 6 hours goes up 2, and now I can kind of see how big these are coming apart. This is great. It's used in business all the time. If this were money and I'm looking at profits, I want to see things like this. This is what it's used for. You have a practical sense. You want this practical problem in here as well so that they see the use for this right away. And we want something that's a clear explanation of why we're graphing linear equations in the first place, and also how to do it and how to understand it. Okay. I feel like I went long on this video. I try to keep my videos short, so I'm going to end it right here. If you have any questions, go ahead and put those in the comments, likes or comments. Even if you don't like the video, something's going on, you have tips for me to do better videos, because I know the concepts are good, but maybe my presentation could use some work. Go ahead and let me know in the comments. Press the like button and go ahead and subscribe. More videos to come. Easy breezy math tips for teachers. You guys have a great day. Thank you.